Hello. So let us try to look at the problem set question number 79 and on. All right. So first number 79. So when you look at the series 1 plus x squared, and as it goes on, which add up to 4, you have to realize that this one is in fact a geometric series because the term right after the first term is found by the multiplying by a constant ratio. In this case, r will be equal to x. Now, assuming that r will be less than 1, we can establish the fact that sum of this one, which is equal to sum, is the first term, which is 1 over 1 minus the ratio, which is x, has to be equal to 4. Then we can simply cross multiply them. We end up getting 4 minus 4x will be equal to 1. Then we get to realize 3 is equal to 4x. By dividing it by 4, we'll realize that x must be equal to 3/4, and which is in fact less than 1. So therefore this one is satisfied. Alright, let us move on to the next question. Number 80. If 5 geometric means are inserted between 8 and 5, 8, 32. So let's look at it. So we have 8. And then 5 numbers has been embedded in 2, 3, 4, 5. And then we have 5, 8, 3, 2. Find the fifth term in the geometric sequence. Fifth term, that means 1, 2, 3, 4, 5. That's basically what we're looking for. Then here, alright, then let us try to look at this one for a second. If you to assume that 8 is equal to, in fact, 2 to the 3 power. And here, if you to break this one down, let's look at it, 5, 8, 3, 2. What if you were to break this one down by, let us say, 4 as an example? Then becomes 1, 1, 6, 5, 8. Now that's basically what we end up getting. We can break this one down further. What if you have to go for 4? Then this becomes 8, 2, 9. Now, then in this case, in fact, if you have to divide by 4, this one would have been, I'm sorry, I made a silly mistake here. Instead of 1, 6, 5, 8, this would have been 1, 4, 5, 8, and this becomes 7 to 9. And the 7 to 9 is in fact 3 and 243. Here 3 and 81. And we can continue, or 3 to the 4th power. So in other words, this becomes 2 to the 3 power times 3 to the 6th power. Now, one way which we can get this one done is 2 to the 3 power was there in the beginning and also at the end. But difference of the 6 terms, including from 8 through 5832, would have formed by 3 to the 6th power. And which number do you think we would have multiplied so that we can get here? One possible answer is 3. So in fact, if you have to multiply by 3 each time, then this one would have been 2 to the 3rd power times 3 to the 4th power. That would have become our answer. Now let's try to see what that value would have been. This becomes 81 times 8. So in this case, our answer becomes 648. That becomes our final answer. Alright, let's look at number 81. So we have 1 over 7 plus 2 over 7 squared plus 1 over 7 to the 3rd plus 2 over 7 to the 4th. Now, and then it goes infinitely many, and we can kind of be able to see the pattern. But if you have to, one way which we can do this one is if you have to assume 1 over 7 plus 1 over 7 squared plus 1 over 7 squared. That's how we can describe 2 over 7 squared. And third one is 1 over 7 to the 3rd. And then fourth one is 1 over 7 to the 4th plus 1 over 7 to the 4th. You see, Next one would have been 1 over 7 to the 5th. And next one, even though it doesn't show, it would have been 1 over 7 to the 6th plus 1 over 7 to the 6th power. And so forth and so on. In fact, what I have done was I dissected this one series, given series, into two different ones. In fact, this one turns into 1 over 7, which was the first term, over 1 minus the ratio, which is 1 over 7. Then this one simply becomes 1 over 6. On the other hand, this one becomes 1 over 7 squared divided by 1 minus 1 over 7 squared. In fact, in this case, this one becomes 1 over 48. So when you combine these two things together, because this one can be rewritten as 8 over 48. So when you combine them together, our answer is 49. Oops. 9 over 48. You can divide top and bottom by 3, then we end up getting 3 over 16. And that becomes our final answer. Alright, let's look at number 82. The sum of the first three terms of geometric sequence is of the positive integer is equal to the 7 times the first. So sum of the first three terms. So we can call it maybe x plus xr plus xr squared. That must be equal to the 7 times the first term. So 7 times x. And the sum of the first four terms, or except four, it should be 4 terms. So we have x plus xr plus xr squared plus xr cubed must be equal to 45. Then what is the first term of the sequence? Then one thing that which we get to realize is that these three terms can be replaced with 7x. So if you have to do that, then we end up getting 7x plus x to the x times r to the third power is equal to 45. Now that means we can factor out x, then we end up getting 7 plus 4, r to the third power. Given that all these things are integers, then what we can do is we can break down 45 into two factors, pair of factors at the same time. It can be 1 and 45, and 3 and 15, and 5 and 9. Now, but what if x were to be equal to 1, then this one has to be 45. Given that this one is already 7, that means r cubed has to be 38, which is not possible for r to be an integer. How about the second case? If x equals 3 and 7 plus r cubed is equal to 15, that means r cubed must be equal to 8. Oh, wait a minute, that works out if r is equal to 2 while x equals 3. Alright. Then what is the first term in the sequence? First term was x, which is equal to 3. That becomes our final answer. Alright, let us try to simplify this one. I mean, there are many ways for us to do it. What if I add up all the even numbers on the top? As long as I subtract all the even numbers, then I'll be okay. So in fact, what I'm trying to do is 1 plus 3 plus 5 plus goes all the way up to plus 199. And then we have 2 plus 4 plus 6 plus up to 200. Now what I'm about to do is, what if I were to add 2 and 4, 6, all the way up to 200? Meaning what I have done was I added all these bottom values on the top. But as long as I subtract them, 2 plus 4 plus all the way up to 200, then I didn't quite change the value of this fraction. What this does is that it will help us to calculate things a bit faster. What is the sum of 1 through 200? That's in fact equal to 200 times 201. Oops. over 2. First one plus last one times how many terms we have divided by 2. That's the sum. Minus. Now, in fact, if you have to look at this one more time, you can factor out 2's in all the numbers. Then we end up getting negative 2. Obviously 1 plus 2 plus 3 plus all the way up to 100. That means the second portion becomes negative 2. Actually, we factored out the negative sign, so I'm just going to say 2. And then 1 through 100. That means 100 times 1 over 1, sum of the first and the last, divide the whole thing by 2. Now, then in fact, what's going to be happening is this. All over denominator, since the denominator is exactly the same thing too, I can multiply that right over here. Then let us try to calculate things one. So here, cancels out becomes 100, and cancels out. Here we get cancels out. Then 100 is common in all three terms, so if you have to factor out 100. Then 201 minus 101, which is 100, over 101. And that becomes our answer. Find number 84. Find x so that the sequence these three are arithmetic progressions. The fact that it's an arithmetic progression, the difference between these two must be equal to difference between these two. In other words, we can do say 2x plus 2 minus 4x minus 1 has to be equal to 2x minus 3 minus 2x plus 2. Then here we get negative 2x plus 3 is equal to, here 2x's cancels out, then we have negative 5. The negative 2x must be equal to negative 8, where x equals 4. You see, if x were to be equal to 4, then this becomes 15. Here, 10 and 5. So those are the numbers that which we could have seen. Number 85. Let's try to calculate this one. Well, it's very complicated. What we can do is let us try to look at the first one, just to see what's going on here. To rationalize the denominator, what we can do is we can multiply by its conjugate. So we end up getting radical 2 minus radical 1. Multiplying that top and bottom to radical 2 plus radical 1. So if you multiply the top and bottom, what would have happened is top stays as radical 2 minus radical 1. And then denominator becomes by the difference of squares. We end up getting 2 minus 1, which is equal to 1. Which simplifies to radical 2 minus radical 1. Now, if the first term can be rewritten in this way, then what would have happened to the other terms? In fact, it becomes radical 2 minus radical 1. Multiply that by radical 3 minus radical 2. And then the third one is radical 3, or actually radical 4, plus or minus radical 3. And it would have continued. And at the end we have radical 5 of 25 minus radical 24. Now, then you will realize that actually each one would have been plus sign, not multiplication. Then these two would have cancelled out because one is positive, one is negative. So as the radical 3's would have been cancelled out too. And radical 4 would have cancelled out with something. Even here, the last number, square root of 24 would have been cancelled out. Then what's left here is negative 1 from square root of 1, and then plus 5, which will be equal to total 4. That becomes our answer. Alright, we'll stop here and have a nice day. Bye-bye.